My students hate solving quadratics, and you might hate solving quadratics too. So that's what we're going to do today. We're going to solve quadratics by factoring, by completing the square, and also by using the quadratic formula, all right? So normally your teacher gives you an assignment and it'll say in the directions which type you want to use in order to solve that set. So whether it's factoring, completing the square, using the quadratic equation, maybe skip to that part in the timestamps of the video player down below. And without further ado, let's solve some quadratics. Before we do number one, these are all really hard examples, right? So I'm going to do two of each type, factoring, completing the square, and the quadratic equation. So here's the first one. It says 16x squared minus 2x equals 5, and the directions tell us to solve this by factoring, all right? So when we solve by factoring, we want this to equal 0, which means anything over here I need to move to the other side. In this case, I would subtract 5 on both sides to get 16x squared minus 2x minus 5 equals 0, all right? And then what you need to do is take your A term times your C term. This is A, B, and C. So 16 times a negative 5 is a negative 80. All right, negative 80. And I need to find factors of that either add or subtract to get me to negative 2. In other words, they're going to be 2 apart from each other. And so you can list these out and say, 1 and 80, 2 and 40, and keep going. But I know right away that 8 times 10 is going to be just 2 apart from each other. All right, so then what we need to do is split this up so it becomes factoring by grouping. All right, so it's going to be 16x squared. And I think if I use an 8 and a 10, that's the 8 and a 10. In order to be a negative 80 and a negative 2, I think the 10 would have to be negative. When I add those together, that would give me a negative 2. So when I split this, I'm going to say negative 10x and positive 8x. And then the minus 5 comes down from over here, equals 0. So from this step to this step, those two things are equivalent. They just look different, and it's going to be advantageous to us so we can factor this by grouping. All right, so let's see. If I group my first set together, first two terms and the second two terms, I can take out, it looks like maybe a 2x is all I can take out of that first group, leave me with 8x minus 5. And out of the second group, remember I need this to also be 8x minus 5 for my second set down here. So I think I'm just going to take out a positive 1, because that is just 8x minus 5. And since those two match, I know I did it correctly. All right, we're going to write our outside parts together, 2x plus 1, and our inside, just one of those, because it's like we're factoring one of those out. And remember, this still all equals 0. I should have been bringing that down the whole way. Okay, in order for this to be true, to equal 0, I need to set this part equal to 0 and this part. And when I do that, on this side, if I subtract 1 divided by 2, x would equal negative 1/2. And on the other side, if I add 5 and divide by 8, x equals positive 5/8. All right, let's try number 2. All right, the second factoring one that we're going to do says 15x squared equals 2 minus 7x. So again, we have to not only move our 2 minus 7x over, since their squared term is over here, but we also have to put it in the right order. All right, and typically this goes x squared, x, and then no x, or 2, 1, none is how you might think of the exponents. All right, so if I move that over, it's going to be 15x squared. Then my 7x is going to come over and I have to add it. So plus 7x, and then subtract the 2 over, minus 2, and then all that's left on the right side is just 0. This is our A, our B, and our C term. So if I take my A times my C, the coefficients there, that's going to be negative 30. And negative 30, if I have factors of that can add to be to 7, either add or subtract to be 7. Again, I'll just write out all the factors here for you. Okay, so the factor pairs, I think, are 1 and 30, 2 and 15, 3 and 10, and then 5 and 6. And we're looking for ones that are either 7 apart from each other or add to be 7. And I think the ones that are 7 apart, the only ones that really do that are the 3 and the 10. And if I make the 10 positive and the 3 negative, this would add to be positive 7 and also multiply to be 15 times negative 2, which is negative 30. Okay, so when I split these, again, I'm bringing down the 15x squared, bringing down the negative 2, and splitting my middle term to look like this. All right, and if you did it in the opposite order, if you did negative 3x here and positive 10x over here, you would get the same answer in the end. It really does not matter how you split those. But notice that from this line back to my original line, if I were to put those back together, I would still have that 7x, so this is okay to do, to split that. All right, now we need a factor by grouping, so I'm going to group my first two and my last two terms. By the way, if grouping is something that's completely foreign to you or you're not sure how to do that, here's a whole playlist on factoring, including factor by grouping. You might want to check that out if you're not sure what I'm doing here. Okay, but I am going to factor out a 5x, I think, is what I can take out from this group, leaving me with 3x plus 2. And again, in this side, I also need this leftover set of parentheses to be 3x plus 2, which means my signs are switching, so I better take out a -1 from that group. All right, and again, this equals 0, so I better put my 5x minus 1 together, the outsides, and then one of the insides, 3x plus 2. And I have to set both of those sets of parentheses equal to 0. If I set 5x minus 1 equal to 0, I would add 1 and divide by 5, so x would equal positive 1/5. And in this one, I would subtract 2 and divide by 3, so x would equal negative 2/3. All right, let's see if we can do some completing the square problems. Like I said at the beginning of this video, these are really hard problems that we're doing today. So when we complete the square, we solve by completing the square. If you need an easier couple problems, you might want to check out this video up here. I go over some kind of basic ones and I kind of work my way up. And then maybe you can work your way up to a problem that looks like this, right? This is kind of ugly to start with. But let's try it. It says x squared minus 3/4 x plus 1/8 equals 0. Now, whenever you complete the square, you have to have a 1 as your coefficient in front of your x squared. All right, so we're going to start by moving our constant term to the other side. All right, just like normal completing the square. This is x squared minus 3/4 x, and then you leave a little space, and I'm going to subtract the 1/8 over by going negative 1/8. Okay, then we're going to take half of our b term and square it. Now, when I say half of our b term, remember the word of there means multiplication. So you can literally take 1/2 times your b term, 3/4 in this case, all right, and then square that. Well, in the inside of that set of parentheses, this, on top we're going to have 3, on the bottom we're going to have 8. So this will be 3 over 8, quantity squared, and then you can square the top and the bottom of that fraction. And on the numerator, we would get 9, and the denominator, of course, that would be 64. All right, so I'm going to add in 9/64 to both the left side, and I have to do it to the right side, plus 9/64 over here. All right, and then the way that you write the left side as a binomial squared is you're going to take the a and the c term and take their square roots. And so the square root of x squared is x. The square root of 9/64, well, we just squared it, so it's going to be this, right? Or you could just go backwards and say the square root of 9 is 3, square root of 64 is 8. So 3/8. And then the sign that you use for this left side is the sign that comes in front of your b term, in this case a negative. Remember, this is a binomial square. Don't forget your squared there. Equals, and then you'll probably need to do some sort of common denominators on the right side here. And I know that if this is an 8 and this is a 64, I better multiply both the top and the bottom of this one by 8 in order to get negative 8 over 64. And then I can say plus 9/64 over here. Right, negative 8/64 plus 9/64 is just 1/64. 1/64, which that looks kind of ugly, but it's actually going to be pretty nice because we'll eventually square or take the square root of those things, and those are both perfect squares. Here it says x minus 3/8 quantity squared equals 1/64. To get rid of the squared here, I need to take the square root of the entire thing, which means I better do it to the other side as well. And here the square root and the square will cancel, leave me with x minus 3/8. Okay, equals, and like I said, the square roots of 1/64, well, this is the same thing. There's the property of fractions that say I can take the square root of the top and the bottom. And the square root of 1, of course, is 1. The square root of 64 is 8. And then whenever you take the square roots and they don't cancel like they do on the left side, you do need to have a plus or a minus in front of that number. All right. And then what I need to do is move my 3/8 to the other side to get my x isolated. That's our whole goal, is finding the zeros here. So x equals positive 3/8 if I add it over, and then plus or minus 1/8. And you can do this as two separate cases, right, since they both have a denominator of 8. So 3/8 plus 1/8 would be 4/8. Which of course is just 1/2. There's going to be one answer. And then 3/8 minus 1/8 is 2/8. So 2/8. which of course is 1/4. So the two answers for this problem that satisfy this equation when we find its zeros are 1/2 and 1/4. All right, problem number 4, we're still solving by completing the square. It says 16x squared plus 16x equals -32. Now, no matter what the other terms are, whatever comes in front of our x squared term, we have to divide by that number. All right, so it's going to kind of look like I'm taking out a GCF here, but it would be true if this number was, you know, like a 17 or a -33. You would still divide by 16 because that's what's in front of your x squared term, okay? So even though those are all divisible by 16, it just happens to work out that way. X squared plus x equals -2, all right? And then in this one, our constants already moved to the other side for us. So I can kind of create this space right here, take half of my b term and square it right away because that's already moved over. So half of, this is a 1 currently, so half of 1, I'll do a little side work, squared is going to be 1/4. So I have to add in 1/4 to both sides of my equal sign like this. And now I can write this as a binomial squared, which is going to be the square root of both of these things. So x and 1/2. And then the sign that comes in front of my b term, which is a plus, and that's again a binomial squared. All right, on the other side, I do need some common denominators. Right now, my denominator for -2, of course, is 1. So I better multiply both of the tops and bottoms of this one by 4 in order to get -8 over 4. So -8 over 4 plus the 1/4 is going to be -7/4. All right, -7/4 is what I'm left with over on this right side, -7/4. But now I can take the square root of both sides since I'm trying to get the x isolated. So I better do that over here. And this gives me x plus 1/2 equals, and on the other side, I'm noticing something right away, is that the square root of my denominator 4 is possible to take, right? That's going to be 2. And so let me just write this out and say this is going to be -7/4, right? This is the same thing as saying the square root of -7 over the square root of 4, or moreover, it's going to be on the bottom a 2, and on the top I also need to take out an I, right? We can take out an I when there's a negative in our square root, so this would be I root 7 over 2. Okay, so let's write that. I root 7 over 2 is what this simplifies to be. And again, whenever you take a square root, which we did, I need a plus or a minus out in front of that. All right, last step is to get our x isolated by moving my 1/2 over. And I have to subtract that over. So now it's going to be x equals -1/2. Move it over by subtracting, plus or minus that I root 7 over 2. Okay, and then one more step. Your teacher might let you leave it like this, but they might also, if these are the same denominators, they might want you to put those tops together. In other words, it would look like this. X equals -1 plus or minus I root 7, and then all over 2. And then all over 2, just like that. All right, the last two problems that we have to solve by using the quadratic formula, which I wrote over here for us. It's the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. Oh, it's a mouthful, right? So anyway, our first one says 2x squared equals 1 minus 2x. So in order to get our a, b's, and c's, we need to put this in the right order, which again is that kind of 2, 1, none in terms of our exponents. So 2, this one has 1, this one doesn't have any exponents for the x's. So let me do that quick for you. All right, and again, these ones need to equal 0, okay? So 2, 1, none as far as my exponents go. This is in the right order. So to write out my a, b, and c's, here it's just the coefficients in front of your a, b, and c terms. So 2, 2, and -1. 2, 2, and -1. And then I can throw all of that into the quadratic formula and let it kind of do the work for me. All right. So I need the opposite of my b term, which would be a -2, plus or minus the square root of b squared. Well, 2 squared is 4. Minus 4 times my a times my c, 2 and -1, all divided by, and then 2 times a. I like to do 2 times a kind of in my head, which would be 2 times 2, which is 4. Okay, then the part that you need to focus on is actually called the determinant. This is underneath our square root. And let's see, 4 minus, this is going to be 8. and then a negative 8. So 4 minus a negative 8 is 4 plus 8, which is just 12. So this is negative 2 plus or minus the square root of 12 over 4. Now, square root of 12, of course, can be written as the square root of 3, or sorry, let's go square root of 4 first, times the square root of 3. That's important because the square root of 4 is 2. So I'm going to replace my square root of 12 with 2 square roots of 3. So it would now look like this, negative 2 plus or minus 2 square roots of 3 all over 4. Okay, we're getting closer. Now I see that the outsides, this negative 2 and 4, and this 2 and 4 are both divisible by 2. And so I can replace those with, what is that, negative 1 plus or minus, and this would just become a positive 1. Well, 1 times the square root of 3 is still just square root of 3, and that would all be over 2. Okay, and again, your teacher might want you to leave it like this, or they might want you to split that up. So it's negative 1 plus square root of 3 over 2, and negative 1 minus square root of 3 over 2. I let my students leave it just like that. And so x, remember this is x equals both of those numbers. Like I said at the beginning of this video, these, like that needs to go on the blooper rule.